Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. So today we are going to discuss on what we call the second part of our lecture for topic 6, data descriptive, and 6.2, measures of location. Okay, so in this video we are going to construct and interpret box and whiskers plot for ungrouped data and find interpretation of mean, mode, median, quartiles, and percentile for group data. Okay, so this is a sample of box and whiskers plot. Okay, so as you can see that we call for the term of box, there's a box here, and whiskers, there's a line outline here. Get the outline of something like this, it might be disappear in this picture. Okay, and also for this one, I'm sorry. This is straight line, sorry. Okay. It's for a minimum here. Okay, so the vertical box we call horizontal and vertical with the box, and also the whiskers here. Okay, box and whiskers plot is also called a box plot, as seen here, based on the 5 summary first quarter, second, third, and the maximum, and can be represented horizontally or vertically, and sometimes extreme values appear in a set of data which is known as outliers. Okay, so then okay, we look at the step that needed to construct the balls and whiskers here, and it will be more clear when we sketch or try to solve a few examples to see what it's all about. Okay, and this example of the data lies within upper and lower inner fence. So the data has no outlier. Outlier means that the data that might be that separately from others data. Okay. So for example, as this one here, the mean maximum here, and example for the mean, maximum, and there's an upper inner fence, and there's one data that weird or might be different from the others data, which is inside the lower and inner fence. So lower inner fence, upper inner fence, is also the lower and upper inner fence. All this data inside in between the lower and upper inner fence, but for this kind of data, there is one data that weird or might be separately from others data, which is in between the lower and inner fence. So observation that lies outside fence is known as outlier. Shape of data we call distribution, symmetry, and skewness. Okay, so then you can see here now where the data is balanced. Okay, where the data is balanced, the second quarter, the first and the third one here, it looks symmetrical, left and right. Okay, so positively skewed of the left whiskers is shorter than the right whiskers, and the median is nearer to Q1. Okay, so and the symmetry, recall negatively skewed distribution to the left whisker is no longer than the right whiskers, and the median is nearer to Q3. Okay, as you see the screen here now. Example 1. Okay, so these all the raw data that are given to us, and A, display the data in a stem and leaf diagram. Find the first, second, third quartiles, upper and lower inner fence, and construct a box of whiskers for the plot for the above data. Okay, let's solve all these examples now. Okay. So we are going to rearrange all these data from the lowest to the, we call the biggest one, the maximum. So we call the smallest, which I think that begin with 30 something. Is it 32? Oh no, there's all 31 here. So let's say if I rearrange all this, 31, 32, what else? Okay, 31, 32, 4, 35, 36, 7, 8, no. Okay, we none begin with 40, start with 40, 40, 41, and finally it ends up with the, we call the numbers, the value of 70, 72, 70, 79. Is there any 80 there? No, there is no 80. So we call the highest is 72 and 79. Okay. So then let's sketch for the box and record the stem and leaf data. Sorry again. Okay, stem and leaf data. So we begin with 31 and 32. Then come out with 40, 41, 41, 45. Then 50, 51, 52, 54, 55, and 57, 61, 61, 62, 65, 65, 66, 66, 66, 68, and 69, 10, 70, 72, and 79. And don't forget, we need to mention the key for this one here. Let's say 30 and 1 means 31. Okay. So now the number of observation, where the numbers of observation here 31, 32, 40, 41, 41, 55. So we may count just from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. The number of observation is 25, where the minimum here, minimum is 31, and maximum is 70. It's 79 here. Sorry, not 79, 79. Okay, maximum is 79. So the first quartile equal to 1 over 4 times the number of observation, which is 25, equal to 6.25. Then we round up to 7th observation. Okay, 1, 2, 3, 4, 5, 6. Okay, 6, between 6, the 6th observation and 7th observation here, it is equal to 50. 5 and 0 means 50. I should write all. Okay. Then third quartile, second quartile, 1 over 2 times 25 equal to 12.5. So 12.5, the first, second, third observation, 4, 5, 6, 7, 8, 9, 10, 11, 12. Between the 12th observation and 13th observation, 57 and 61. Okay, so it is the 13th observation, which is equal to 61. Then next, the third quartile, 3 over 4 times 25 equal to 18.75. It is the 19th observation equal to 19th observation, okay, which is equal to 66. Okay, 1, the first, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. 66 and 66. These are 18th observation and 19th observation. So it's all here with 66. Okay. So then upper inner fence equal to Q3 plus 1.5 times with Q3 minus Q1. Okay, where Q3 equal to 66 plus 1.5 times with 66 minus Q1, which is 50. And this gives you 90. Okay, and then okay, again, I write everything in one page here. So lower inner fence, equal to Q1 minus 1.5 multiplied with Q3 minus Q3 minus Q1, which is equal to Q1 equal to 50 minus 1.5 times Q3, 66 minus Q1 equal to 50, that is equal to 26. So now we are going to sketch, or we call sketch, a picture of box and whiskers plot. Okay, so okay, then with 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so the lower inner fence just now, lower inner fence equal to 26. and upper inner fence equal to 19. Okay. Lower inner fence equal to 26 and upper inner fence equal to 90. Okay, this is lower inner fence, and for 90 it is upper inner fence. Okay, and then for 31, the first quartile, okay, the first quartile equal to 50. The first quartile equal to 50, and the second quartile equal to 61, and the third quartile equal to 66. Okay, the first quartile, second quartile, and the third quartile here equal to 50 and 61. Supposed to be here 61 and 66. Okay, 50. This is 61, and this is for 66. Well, 79, okay, 79, and also 31. There you go. The value of 79, and also here is for 31. Okay, so no outlier. There is no data that outside of this upper inner fence. Okay, there's no outlier. The data is negatively skewed. Okay, skewed to the left. So there's a tail on the left here. Okay, so this is it for the first example. And now second example, example number 2, is given that here, from the given stem and leaf diagram, construct box and whiskers data, determine the outliers of the data. Okay, just now in example 1, they give you a raw data, and we need to form a stem and leaf diagram, something like this, and we analyze, and after that we come up with a box and whiskers data. So right now, it's already give you the data in the form of stem and leaf data. Okay, stem and leaf diagram. So we are going to use this data in the stem and leaf diagram, then construct a box and whiskers plot and determine the outliers of the data. Okay, sorry then. Okay, so now from the observation, okay, the numbers of observation, there are 23 of them. Okay, 51, 59, 62, 63 until 76 and 77. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So the numbers of observation are all 23. So then 1/4 times 23 equal to 5.75. So we come up with observation number 6, the 6th observation as a Q1, okay, as a first quartile, which is equal to 64. Okay, second quartile, which is 2 over 4 or 1 over 2 times 23 equal to 11.5. That makes at the 12th observation, which is equal to 68. And the third quartile, or 3 over 4 times 23 equal to 17.25. So that makes that the third quartile is the 18th observation. Okay, 18 observation equal to 70. So, okay, now, let's say first quartile 1 over 4 times 23, 6 observation. Okay, look at this one here now. It begins with 51. 51, then 59, then 62, 63, 63, 64. So this is the first observation. Second observation, the third one, fourth, fifth, sixth. Okay, 1, 2, 3, 4, 5, 6, and the seventh observation is also 64. Okay, so then now, sixth observation I see here now is 64. So this is it. Means that you may continue the rest of the until the 22nd and 23rd observation. Okay. And now, upper inner fence equal to Q3 minus plus 1.5 times with Q3 minus Q1. So now, from here, we try to find out the upper inner fence. We using the data of Q3, which is 70, plus 1.5 times Q3, 70 minus Q1, which is 64. Okay, so here it comes out with 79. And lower inner fence equal to Q1 minus 1.5 and Q3 minus Q1. Q1 equal to 64 minus 1.5 and Q3 70 minus Q1 64, and this gives you 66 degree Fahrenheit according to the data then. Okay, so then the outlier equal to 51, where the mean equal to 59 and maximum equal to 77. Okay, class. According to the data that we given earlier, the minimum is 51. Am I right? Okay. But then now, because we got no, this is not 66. Sorry. It is not 66, and this is 55. Okay. Because earlier, from the stem and leaf, from the stem and leaf diagram, the minimum is 51. But then using the lower inner fence formula, then we find out the lower inner fence is 55. So, if the lower inner fence is 55, then the minimum is not 51 anymore. 51 is the outlier, the data that means outside of the fence. Okay, so if I sketch this, from, if I use a scale of 50, 60, 70, and 80, the lower inner fence is 55. Okay, lower inner fence, and 51 is somewhere around here. Then the minimum is now not 51 but 59, the first value which is inside the lower fence, lower inner fence. This is outside. So, and then the first quartile is 64. This is the first quartile, 64. And then second quartile, 68. Okay, second quartile which is 68, and the third quartile equal to 70. Okay, there you go. This is 70, and then maximum is 77. And this is 59. That's it. And the upper inner fence is 79. This is upper inner fence. Look at this one here now. The minimum 51 is outside the lower inner fence, so this becomes the outlier. So data, I call the data is negatively skewed or skewed to the left. Okay. So this is a picture of a box and whiskers plot for the example number 2. And this is the outlier. Okay, so we will look into what we call the next part of this topic, subtopic, which is measures of location. So we are going to discuss what is mean, mode, and median, percentile, and quartile. So the mean of frequency distribution, as you see here now, mean average equal to the summation of f multiplied with the x divided by summation of f. So f is total of number of frequency and x is a class marks. Okay, so this is it. The total of the frequency. Okay, the frequency is all here, and the frequency within each classes. Okay, for example, let's say the numbers of x that appear which is in the range of 0 and 10. It might be 2 and 4. And that we call the numbers in between 10 up to 20, it appears 70 times. So it might be 11, 11, 11, 12, 13, and 13. Okay, 1, 2, 3, 4, 5, 6, and count on until might be until the 17 times. As long as the numbers lies in between 10 until 20. Okay. So all this raw data we processing until we can come up with this we call table and make a class for each range of x. They are what we call the same here. I'm going to say this all in the same range of 0 to 10, 10 to 20, 20, 30, and all that. Okay. Okay, now, okay. So in this case, let's sketch the recorder table again. Okay. And so then the class, okay, class mark with an X and frequency of F and also F multiplied with an X. So frequency multiplied with the class marks. For example, here X in between 0 up to 10, and here 10 up to 20, 20 to 30, 30 up to 40, 40 up to 50. Okay, then the frequency for each of this 2, 17, 26, 10, and 5. Okay, so now okay, so class, the summation of frequency here 2 plus 17, 19 plus 26. Okay, 19 plus 26, 19, 29, 39, 45 plus with 10, 55 plus another 5 equal to 60. Okay, so class marks X is a middle point, midpoint of, we call the maximum, the minus with the minimum of each of these, the lower class, upper we call value divided by the lowest here, which is 10 plus 0 divided by 2 equal to 5, and this one here, the midpoint between 10 and 20, so 20 plus 10 equal to 30 divided by 2 equal to 50. So then here it is 5, 15, 25, 35, and 45. Okay, so the first one then, average or mean equal to summation of F times X divided by summation of F. So means here the class marks summation of F times X for frequency times with the midpoint, the class marks or midpoint. Again, I put it here, the name that makes you recall, that make you clear with it. Class marks or another term which is midpoint with the X here, 10 plus 5 divided by 2, it is 5. 20 plus 10 equal to 30 divided by 2, 15. 15 is a midpoint between 10 and 20. Okay, then 5 times 2 equal to 10. Okay, 5 times 2 equal to 10. Then 15 times 17 equal to 255. 25 times with 26, 650, and 35 times 10, 350, and 45 times 5. 45 times 5 equal to 225. So that the summation of fx equal to, okay, now 10 plus 255 plus 650 plus width 350 plus width 225 equal to 1490. Okay, then summation of fx here 1490 divided by summation of f equal to 60. Then it is equal to 24.83. Okay. So the mode of frequency distribution. So you may read all this from your lecture notes, and let's continue with the, okay, so all the definition of L, lower boundary, D1, difference of frequency, model class and frequency before the frequency of the class, immediately before it, D2, and the C, size of the mode class. Okay, find the mode of frequency of each of the distribution given below. Okay, so look at the range of data here, 15 to 19. We count it like this. A class of 15 to 19, 15, 16, 17, 18, and 19. So the size is 5. Okay, the size is 5. 15, 16, 17, 18, and 19. So the size is 5. And from this data, from this table, we call the data in the class of 30 to 34 with the highest frequency, which is 35. Okay, so from this data, the highest frequency, okay, highest frequency is 35. Okay, the mode class, so the model class is the class which is we call the data, the range of 30 up to 34 is here. Okay, 35 and the model class of 30 to 34. And then look at this one here now. The L, the lowest, or we call the lower boundary of the class, model class, which is 29.5. Lower boundary. Okay, L, lower boundary of model class. Lower boundary means there is the value in between 30 and the upper class. We call the upper boundaries here in between 29 and 30. So class, let's say between 29 and 30. From 25 to 29, there's one class. And from 30 to 34, another class. So in between 29 and 30, there's a lower boundary. Okay, lower boundary means that plus and minus, plus minus 0.5, and here is 29.5. Okay, so then okay, so in between 29 to 30, there's a we call middle point here, which is 29.5. L is 29.5. Then D1 and D2. So what's the definition of D1 and D2? Okay, you may refer to your lecture notes. D1 is different between the frequency of the model class and frequency of the class immediately before it. So it's between 35 and 22. Okay, so 35 and 22. Okay, so D1 is 35 minus 22, and D2 is what we call the difference between frequency of the model class and the frequency of a class immediately after it, which is 35 minus 20. So, 35 minus 22, which is D1, 35 minus 22, and 35 minus the frequency immediately after it, and we put this as a D2 equal to 35 minus 20. Okay, so 35 minus 22 equal to, 35 minus 22, 5 minus 2 equal to 3, 3 minus 2 equal to 1, 5 minus 0 is 5, 3 minus 2 equal to 1, 13 and 15. D1, 13, D2 is 15. And then the class size equal to 5. Okay, so then the mode equal to 29.5 plus width D1 equal to 13, D1 plus D2 equal to 13 plus 15 multiplied with the size of the class, which is equal to 5. So use a calculator and it gives you 31.8. Okay. For median of frequency, okay, so this is a formula, and LK stands for the lower boundary of the median class, total frequency, Fk minus 1, the cumulative frequency. Look at this one here. Use the capital letter of F, and the small letter of f here, the frequency of the median class and the size of the median class. Okay, so this is the example given to us. Calculate the median for the following data. Okay. Okay, look at the solution here now. Okay, I rewrite everything here again. Frequency. Okay, for that. Okay, which is here equal to 7, 27, 35, 54, 63, 43, 25, 17, 9, and 4. Okay, let's recall sum and all this recall frequency of data here. 7 plus 27 plus 35 plus 54 plus 63 plus 43 plus 25 plus 17 plus 9 plus 4, where the summation of f here equal to 284. We can also put this as a number of data. Okay, now for cumulative frequency, capital of f here, first is 7. 7 plus 27, 34. 34 plus 35 equal to 69. 69 plus 54, 123. 123 plus 63 equal to 186. 186 plus 43 equal to 229 plus with 25 equal to 254. 254 plus 254 plus 17 equal to 271. Okay, 271 plus 9 equal to 280, and plus with last one here 4 equal to 284. Okay class, the number of data equal to 284. Cumulative frequency must end up with the same value of the number of data here. It must equal. Okay. Now, we call the midpoint between from the beginning of 0 until 284. 284 divided by 2 equal to 142. Okay, now class. Okay, from 0 up to 7. From 0 up to 7. And then plus with 27, it end up until 34. And then 69. Then 123, the cumulative frequency here, until 186. Okay. So accumulate from 0 plus 27, 34. 34 plus 35, it gives you 69. So it could accumulate from 1 to 1 value here until 123. By the way, 142 lies in between, let's say, 11, 23. Just imagine that there is a we begin here with 24. 123, so 124. So then 142 lies in between 124 and 186. 142 lies in between 124 and 186, meaning our median class lies in this range. Okay, our median class lies in between this range in the class of 20, x of 20 until 25, with a frequency of 63 and cumulative frequency of 186. So, from cumulative frequency accumulate from one frequency to another. So 7, 34, 69, and 123. So we begin with 124 up to 186. And 142 lies in between 124 and 186. So it lies here. Then the median class 284 divided by 2 equal to 142. So then the median class is x lies in between 20 up to 25. And we seen from the previous page where LK equal to 20. Lower boundary of the class, okay, 20 to 25. The lower boundary class here is 20. And then the number of data equal to 284. Cumulative frequency of the data class before the median class equal to 123. Okay, for cumulative frequency of the class before the median class, 123 here. Okay, cumulative frequency before the median class is 123. Okay, and then frequency of the median class here equal to 63. There you go. This one, 63. And then size of the class, which is equal to 5. Now, median equal to lower boundary of the class 20 plus, okay, so 1 over 2, 284 minus 123 divided by 63 times 5. Okay, median 284 divided by 2 minus with the frequency of the frequency before the median class 123 divided the frequency of the median class, and this gives you 21.51. Okay. Quartiles and percentiles. Quartiles divide a set of data which are arranged in descending orders into 4 equal parts. And percentile divide a set of data which are arranged in the ascending order are into 100 equal parts. And this is it. Okay, then the upper quartile, third quartile, and the second quartile, or P50, is also called median. Okay, so this we call the formula, which I think that you may refer to recall your lecture notes. Okay, from the above data, calculate the first quartile, third quartile at the 19th percentile. Okay, so now from this table, lower boundary means that we call from this class limit, okay, from 3 to 5, 1 class, and then 6 to 8, another class, and then 9 to 11, another class. Okay, so then there is a boundary that divides. There's a boundary that divides between these two classes, which is midpoint or half of between 5 and 6, and also here. Okay, and also here. So just imagine that if from between this gap, okay, between this gap, we minus 0.5. Between 5 and the middle point here, we add up with 0.5, and 6 between this, we call middle point here, it is minus 0.5. So between these two, it is plus 0.5, and between this here is also minus 0.5. So between this is upper limit of the first class, and this is a lower limit of the second class. Between these two, we can imagine that this is a plus minus 0.5. Okay. Okay, now frequency, which is 1 to 11, 10, 5, 1, and cumulative frequency 1 plus 2 equal to 3, 3 plus 11 equal to 14, plus 10, 24, plus 5, 29, plus 1 equal to 30. So the number of data n equal to 20. Okay. And now from this table, then to answer the first question of A, the first quarter, 1 quarter of 30. Wait a minute. Okay. N equal to 30. Sorry, I make a mistake here. 30, not 20. quarter of 30 equal to 7.5. Okay, so then the class interval of 9 to 11 and then LK, the lower boundary of the class, which is 8.5, frequency of the class equal to 11, cumulative frequency of the class before equal to 3, and the size of the class equal to 3. Okay, class, 7.5 for this one here. Why do we choose this class interval of 9 and 11? Okay, so just imagine that let's say from frequency of 1, then accumulate plus with 2 and come up with 3, plus with another 11 and accumulate until 14, and plus 10 come up with 24, plus 5, 29, and 30. Okay, so now the first quartile, now just imagine that it is from 1 up to 30. So divide by half of this 30 equal to 15. And divide by half, another half is 1/4 here. And 7, we just calculate just now, 1/4 times 30 equal to 7.5. Where is 7.5? It lies in between 3 and 14. 7.5 is around here. Okay, 7.5. So it lies in the third class, because from 1 to 3, from 1 here is class of 3 to 5. And then accumulate until 3 lies in between 6 and 8. And accumulate until 14, it lies in the class of 9 up to 11. So 14 here. From 3 or 4 here to 14, it lies in the range of this class, 9 to 11. Okay, so then that's why we choose this one, class of 9, 11. So the lower boundary of the class is 8.5. So from 9 minus 0.5 equal to 8.5, the lower boundary of the class. Okay, so then the first quartile equal to 8.5 plus with 1/4 times 30 minus 3 and everything divided by 11, the frequency of the inner class, and then times with 3, the size of the class. And it is equal to 9.73. Okay, the first quartile is 9.73 centimeter. And the third quartile times 30 equal to 22.5. So 22.5. Okay, 22.5 lies in between 24 up to 29. So it lies in this class of 15 and 17. Okay, class, sorry, I make a mistake here. It's not between 15 and 17. Okay, 22.5. Okay, 22.5 lies before the cumulative frequency of 24. So if I accumulate until 24, then here is 22.5. So we are talking about this class of 20 up to 14. Okay. So then class interval of 20 to 14, the lower boundary of the class, which is 11.5, the frequency of the class which equal to 10, cumulative frequency of the class immediately before, which is 14, and then the size of the class equal to 3. So the third quartile equal to 11.5 plus width 3/4 times 30 minus 14 divided by 10 multiplied with 3 equal to 14.05 centimeter. So for 19 percentile, so 19 times over 100 multiplied with 30 equal to 27. Okay, so 27 is lies in between 24 up to 29. Okay, sorry. 24 up to 29, so 27 lies in between, so this is the class that we were talking about. Okay, so it is lies in between the class of 15 up to 17, the size of we call the class of 15 to 17, where the lower boundary of the class is 14.5 is 5 here, and frequency of the class before the median class here is 24. We call the 19 percentile 24, and the size of the class equal to 3. So the 19 percentile equal to 14.5 plus width, okay, 90/100 times width 30, the number of data, minus 24, the cumulative frequency, the class before that, okay, which is 24, and divide by 5, the frequency of the 19th percentile, 5 and 24. Let's take a look again. So this is the class, so this is the frequency of the class, and this is the cumulative frequency before the class of the 19th percentile for 24 and 5 here. Okay, and multiply with the size of the class equal to 3, and use a calculator, it will give you 16.3 centimeter. We call 19th percentile equal to 16.3 centimeter. Okay, so that's all for today. And I do hope that this lecture video helps you to understand the content of this and continue with your tutorial and PSPM question. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.